down, which gives them a friendly, smiling appearance. These arcs appear over the sun only when the direction of light and the orientation of the ice crystals are just right, when light enters the top faces of hexagonal plate crystals and exits the side faces. However, this can only happen when the sun is lower than 32.2D above the horizon and more than 5 AGG, because the ice crystals function essentially like a 90 AGG prism. The color separation is excellent, meaning circumzenithal arcs have a far higher degree of clarity than actual rainbows. And if you're really lucky, you might even spot one with moon rings called luna. Circumzenithal arcs. These unusual arcs only appear when the moon is extremely bright and fairly low on the horizon. As strange as it sounds, it is possible to see what looks like an upside-down rainbow at night. Now this is amazing. Circular halos have also been sighted on Mars. Here is an image taken by Perseverance on the 15th of December 2021. This has led some to suggest that the cause may be carbon dioxide crystals in the planet's cold, thin atmosphere, or perhaps a mixture of CO2 and water ice. We didn't always know that halos occurred on Mars. So as you can imagine, the Perseverance team was pretty excited to see this, because the size and appearance of the halos provide clues about the types of crystals forming in the atmosphere. Scientists hope that studying halos here on Earth and spotting them on other planets could shed light on the composition of those planets' atmospheres. As a result, more research will be undertaken in the future to document and understand the appear of ice halos on Mars, as well as other moons and planets. So there you have it, a primer on some of the better-known ice halos and their associated optical phenomena. And if you want to see one for yourself, here are some things to look for. First, check for cirrus clouds. These are the high-altitude wispy clouds that contain the small ice particles needed to produce ice halos. Second, look for the sun or moon, but take care not to stare directly at the sun, kids, because that can damage your eyes, while rainbows form around the anti-solar point, which is located directly opposite the sun in the celestial dome. Most ice halos form in proximity to the sun or moon, and while ice halos tend to appear in fair weather, they often arrive at the front of an approaching storm system, meaning if you see one, it's better not to linger outside for too long. Head indoors, pause, and find somewhere cozy to enjoy the upcoming storm. So if the weather is fair, but you see rain in the 24-hour forecast, keep an eye on the sky. Your chances of seeing a halo will be higher. Of course, the best way to see one is to look every day. Ice halos can form anywhere on Earth, so if you keep looking up, you're bound to see one sooner or later. But when it comes to ice halos, there's plenty more to talk about. There are a lot of other strange and even rarer kind of halos, and probably more yet to be discovered. So if this is a topic you like to see more about in the future, and if you've seen them for yourself, I'd love to hear about it in the comments. The Solar and Heliospheric Observatory, also known as SOHO, recently celebrated its 25th anniversary in space. During these 25 years, it has observed the solar wind, watched out for dangerous coronal mass ejections, and observed the atmosphere of the sun. An unintended consequence of his observations around this region was the discovery of over 4,000 sun-grazing comets, most of which we had no idea existed until they came into SOHO's view. And SOHO isn't the only solar observatory. The Stereo spacecraft and the Solar Dynamics Observatory have all seen new comets. And what's so cool about that is that they weren't designed with that in mind at all. I'm Alex Molan, and you're watching Astram. And in this video, I wanted to look at some of the most impressive of these comets. Try to understand how they interact with the sun, and how the sun interacts with music. The Msu grazers are comets that do just that. They graze the sun as they pass, with the closest parts of their orbits, taking them within a head's breadth of the sun's surface. Often they will pass through the sun's huge atmosphere called its corona. These comets are mainly long-period comets. Comets whose orbits take hundreds to thousands of years to complete because of their orbit's extreme elliptical nature. They build up tremendous speeds as they approach the Sun, sometimes accelerating to 0.2% of the speed of light, an absolutely incredible speed for a particle, let alone a house-sized object. The majority of Sirius comets actually all originate from one large comet that was ripped apart several hundred years ago. This group of Sue grazers, shown in red in this video, is known as the Sue grazers. What tends to happen over time is that the fragments from the larger comets spread out, meaning that there is probably a steady flow of them as the largest of these comets also pass by the Sun. They too break apart into even smaller comets. And the reason we believe most sungrays originate from the same comet, well, they all tend to follow the same orbital path. The brightest comet in the last millennium, known as Comet Ikaski, was probably a fragment. It was so bright as it approached the Sun that it could even be seen during the day. You may have heard of another famous fragment of this comet that dimly illuminated the sky in the southern hemisphere in 2001 called Comet Lovejoy. While Comet Lovejoy wasn't as bright to the naked eye, it did make for some very impressive long exposure.